energy stored by a charged metallic sphere. Energy stored in the whole space outside a charged metal sphere, that is in the electric field produced by the charged metal sphere of radius capital R, containing a charge Q. Energy stored in the whole space outside a charged metal sphere, that is in the electric field produced by a metal sphere of radius R and containing a charge Q. This is a charged metal sphere. And this metal sphere is charged. O is the center of the sphere. And this metal sphere is charged. And the positive charge plus Q charge is uniformly distributed over the surface of this charged metal sphere, and no charge exists inside the space of the sphere. The charge capital Q exists on the surface of the metal sphere, but no charge exists inside the sphere. We consider an imaginary sphere inside the charged sphere, and x is the radius of this imaginary sphere. This is the elementary portion of the imaginary sphere of radius x. We consider a point, and here we can denote the radius of the charged metal sphere. Capital R is the radius of the charged metal sphere. P is a point. Unit positive charge is placed at P. Unit positive charge, that is +1 charge, is placed at P. Dx is the width of this elementary sphere of radius x, and field intensity at P is E, which acts radially outwards. And this is the small element of the imaginary sphere of radius x. The energy density of the imaginary sphere of radius x is given by small u equal 1/2 epsilon 0 e square. Small u equal 1/2 epsilon 0 e square, where E is the electric field intensity. At the point P, in the elementary portion of the imaginary sphere, due to this imaginary sphere of radius x, and E equal 1/4 pi epsilon 0 q by x square, where q is the charge which is given to the metal sphere, and though the charge plus q exists on the surface of the metal sphere of radius capital R, it can be assumed that this charge plus q is to be concentrated at the center O, and electric field intensity is E at the point P, And this electric field intensity E, which is the force experienced by unit positive charge at the point P. Therefore, at P, E equal 1 by 4 pi epsilon 0 q by x square. Therefore, small u equal 1 by 2 half epsilon 0 under bracket 1 by 4 pi epsilon 0 q by x square whole square. Small u equal 1 by 2 epsilon 0 1 by 4 pi epsilon 0 q by x square whole square. This is the energy density. This is the energy density of the imaginary. This is the energy density of the imaginary sphere of radius x. Small u equal 1 by 2 epsilon 0 1 by 4 pi epsilon 0 q by x square whole square. That is the energy density of the imaginary sphere of radius x. Therefore, the energy contained in the sphere, the energy contained in the spherical small element of thickness dx is given by d capital U equal small u into volume of the spherical small element of thickness dx. D capital U equals small u into volume of the spherical small element of thickness dx and radius x equals small u into 4 pi x square dx. Now we can denote the spherical small element of the sphere of radius x. This is the spherical small element of the sphere of radius x and thickness dx, which has the volume. This spherical small element has the volume 4 pi x square dx. The volume of the small spherical element is 4 pi x square dx. Now, volume of the sphere of radius x is 4 by 3 pi x square. V equal 4 by 3 pi x square, which is the volume of the imaginary sphere of radius x. Therefore, ddx of V equal ddx 4 by 3 pi x cube, or dv by dx equal 4 pi x square. Therefore, dv equal 4 pi x square dx. 4 pi x square dx, that is the volume. dv is the volume of the spherical small element of radius x and thickness dx. Thickness of this spherical small element is dx. This is an imaginary sphere of radius x, which has the volume V equal 4 by 3 pi x cube. Now we consider small element of thickness dx of this sphere, small element of this sphere of thickness dx. And this small element is denoted in this way. This is the small spherical small element, and which has the volume dv equal 4 pi x square dx. dv is equal 4 pi x square dx, which is the volume of spherical small element of thickness dx. Therefore, d capital U equal 1 by 2 epsilon 0 under bracket q by 4 pi x epsilon naught x square whole square into 4 pi x square dx, or d capital U equal 1 by 8 pi epsilon 0 q square by x square dx. Q square by x square dx. D capital U equal 1 by 8 pi epsilon 0 q square by x square dx. Therefore, total energy contained in the whole space outside the charge sphere of radius capital R is given by capital U equal integration du r to infinity. Integration r to infinity du. Now integration is done from x equal to r to infinity, and this energy is contained outside the space of this of the sphere. and this space contains this energy capital U, contains this energy capital U, equal integration r to infinity, integration r to infinity 1 by 8 pi epsilon 0, 1 divided by 8 pi epsilon 0 q square by x square dx, q square by x square dx equal 1 by 8 pi epsilon 0, 1 divided by 8 pi epsilon 0, q square is taken outside integration, integration r to infinity x to the power minus 2 dx equal 1 divided by 8 pi epsilon 0 q square under third bracket x to the power minus 1 divided by minus 1 r to infinity. Therefore, capital U is equal 1 by 8 pi epsilon 0 q square x to the power minus 1 infinity to r, changing the limits, equal 1 divided by 8 pi epsilon 0 q square 1 by r minus 1 by r minus 1 by infinity, 1 by r minus 1 divided by infinity. Therefore, U equal 1 by 4 pi epsilon 0 q square divided by 2r, q square divided by 2r. U equal 1 by 4 pi epsilon 0 q square divided by 2r. This is the energy, this is the total energy, this is the total energy contained, total energy contained in the electric field, total energy contained in the electric field outside the charged sphere of radius r. U equal 1 by 4 pi epsilon 0 q square by 2 capital R, which is the energy contained in the electric field produced by the charged metallic or metal sphere of radius capital R, metal sphere of radius capital R. U equal 1 by 4 pi epsilon 0 q square by 2r. Energy contained in the electric field produced by the charged metal sphere of radius r and charge q. Therefore, we can write down the expression U is equal q square divided by 8 pi epsilon naught r. U equal q square divided by 8 pi epsilon naught r, which is the energy contained in the electric field produced by the charged metallic sphere. Inside the sphere, energy is a U prime which is equal to 0, but outside energy U equal q square divided by 8 pi epsilon naught r. This is a charged metal sphere. This is a charged metal sphere of radius capital R. Plus q is the charge which is uniformly distributed over the surface. We can denote the field outside the charged metal sphere. This is the field outside the metal sphere. The energy stored in the field outside the sphere is U, which is equal to q square divided by 8 pi epsilon 0 r. Capital U equal q square divided by 8 pi epsilon 0 r, which is the energy contained in the field outside the charged metal sphere. Energy contained in the field outside the charged metal sphere. Now, the field inside the charged metal sphere, and in that case, energy contained in the field inside the sphere is U prime, which is equal to 0. As no electric field E acts inside the charged metal sphere, as the no electric field E acts inside the charged metal sphere, the energy contained inside the sphere, the energy contained inside the charged metal sphere will be 0. That is U prime equal to 0. But the energy stored by the charged metal sphere, the energy stored by the charged metal sphere, that is the energy U equal Q square divided by 8 pi epsilon naught R exists exists in the field exists in the field outside the sphere. Now we can consider an imaginary sphere of radius x, and also we can consider spherical small element of width dx. Dx is the width of this elementary portion, and the main charge metal sphere has the radius capital R. A charge plus Q is uniformly distributed toward the surface of this metal sphere. Plus Q is the charge, and this is the charged metal sphere. This is the charged metal sphere of radius capital R. Though the charge exists on the surface of the sphere, you can assume that this charge is to be concentrated at the center O, and here dV is the volume of the elementary portion, and dV is equal to 4 pi x square dx, and small d capital U is the energy contained. In this case, small u is the energy density of this elementary portion of with dx, and small u is equal to half epsilon 0 e square, where field intensity E equal 1 by 4 pi epsilon 0 q by x square, and d capital U is the energy contained by this elementary portion, which is equal to small u into dV, energy density into volume. D capital U is equal to small u dV, and capital U is the energy contained in the field outside the charged sphere, is what capital U, which is integration r to infinity du. Now it is integrated from the point A at x is equal to r to x is equal to infinity, and finally we get this total energy U as q square divided by 8 pi epsilon naught x, q square divided by 8 pi epsilon naught r. U is equal to q square divided by 8 pi epsilon naught r, which is the total energy which exists, or U is equal to q square divided by 8 pi epsilon naught r, is the total energy which is contained in the space outside the charged metal sphere, Plus Q is the charge which exists on the surface of the charged metal sphere. Capital R is the radius of the sphere. Total energy U is equal to q square divided by 8 pi epsilon naught r. Energy contained in the field inside the sphere is U prime equal to 0. This is a charged metal sphere, and energy stored by this charged metal sphere is U, which is q square divided by 8 pi epsilon naught r. Again we can consider that charged metal sphere has the charge q, and this charge q exists on the surface of this sphere, and this is alternative process to find the energy stored by this charged metal sphere. Here we have to assume that this charged metal sphere has a capacitance C, which will be equal to 4 pi epsilon naught r. Capacitance of this spherical conductor is C, which is equal to 4 pi epsilon naught r. C is equal to 4 pi epsilon naught r, and we have to find U equal question mark, that is energy contained in the field outside the sphere. In this case, the capacitance C is equal to 4 pi epsilon naught r. The capacitance of the charged metal sphere or charged spherical conductor of radius r is given by C is equal to 4 pi epsilon naught r. It should be capacitance of a spherical conductor, not capacitor. The energy stored, and this is an alternative process or alternative explanation or aliter. The energy stored by this spherical conductor of radius r is given by capital U equal Q square by 2C, where the capacitance, where Q is the charge of the spherical conductor, and putting the expression of capacitance, you get Q square divided by 2 bracket open 4 pi epsilon naught r. Therefore, U is equal to Q square divided by 8 pi epsilon naught r. Capital U is equal Q square divided by 8 pi epsilon naught r. U equal Q square divided by 8 pi epsilon naught r, which is the energy contained, in the space or field outside the charged metal sphere or spherical conductor.